What we call a capacitor is a device for storing electrical charge for a short amount of time. Now, capacitors don't work for longer. It would be wonderful if they do, but if we store electrical charge in a capacitor, after a little while, the charge is going to leak out and we don't find any of it. To make a capacitor, all what we need is a pair of conductor metal pieces, usually separated by a small distance, like two metal plates. The first capacitor was what we call the Leyden jar. It was the first capacitor that was discovered. Here is a picture of an early Leyden jar. What you have a metal rod that's connected to a metallic surface in the inside of this glass container, and we have a metal enclosure outside the glass container. So the inside metal is separated from the outside metal by the glass. And the Leyden jar was used, actually it was instrumental in a lot of the discoveries about electricity. People, when they first discovered electricity, they didn't have many tools, and the Leyden jar helped them store charges and to be able to experiment with them. So the way it worked, you connect the middle rod. The middle rod sometimes is a chain, like in this picture here, we'll run through the simulation. You connect it to a charge source. From wherever you are connected, producing charges, like rubbing things in a Van der Graaf generator. Here, of course, the cover is made up of insulating material, so the rod does not touch the outside. Okay, we have the glass jar, and what happens is the charge is going to go in and is going to spread evenly along the metallic inside of the container. Now, the outside, we usually connect it to ground. So what's going to happen is that these negative charges are going to repel the negative charges of the outside shell, and then it's going to repel them to ground. So if we disconnect ground, we have a charge maintained within the Leyden jar. I'm going to run this simulation here for a second to show in principle how it works. This simulation is from Florida State University, and this is someone we ask it to charge. So as the charge comes in, it's going to build up around the inside, and we have a charge built up around the outside. Now we can discharge it by connecting the outside to the inside. The discharge wand, what it does, it just connects the outside shell to the inside shell. So that's the early capacitor, a Leyden jar. Now, easiest way to understand a capacitor is to think of this particular one. So what it is made up of is actually just two metal plates, one here and one here, separated by a certain distance. In this case, there is nothing separating them but air. In some cases, we can place other material. Okay, this is a conductor and this is a conductor, so we connect from here and here to charge up the capacitor. Capacitors in use have many different looks. Here is an array of them. These are what's called electrolytic capacitors. They are large capacitors with a large capacitance, meaning we can store in them a lot of charges. We have a ruler here to show us the dimensions, and then we have some tiny ones. This one is called ceramic. These two are ceramic capacitors, and we have what we call tantalum capacitors. I think that green one is, I'm not sure, but this is also an electrolytic capacitor. So they come in various sizes and shapes. Okay, here is more of them, more capacitors. Okay, this is what we call a variable air capacitor. air core capacitor. Now we'll show that in a little bit, and why we call it variable. We'll show it probably in another record. So in principle, what a capacitor is just this. It is two plates separated by air or an insulator. I'm going to run here a simulation to show us a capacitor running. So I'm going to quickly build a circuit by taking a battery, like the circuit that we have seen there, and then a wire, another wire. I didn't need to have so many wires, but for style I like to have a few. Okay, and then a capacitor. That's one end, the other end in the bottom. Okay, and then I'm going to put a switch. Okay. So now everything is connected, but the capacitor does not have any charge, and as we close, actually it happens really fast, as you notice that. As we close the switch, the capacitor charges up really quick. Actually, that's not a good way to charge a capacitor. Usually, we use a resistor here to control the flow of electricity, not to allow it to flow with a high intensity. Okay, now let's see if we run it with a resistor. So it's going to take some time, and you see the buildup of charges. What's interesting, what's to notice here, the end that's connected to the positive lead of the battery becomes positively charged. The end that's connected to the negative lead becomes negatively charged. Now if I open the switch, the capacitor remains charged. For example, here I'm going to split the junction, and I still have a charged capacitor, so I can split it here as well. So I have a charged capacitor that I can move around. In real life, this charge is not going to be maintained for long for most capacitors. Now what I'm going to do is show you an application of using the charge of capacitor is the way, for example, we use it in flashlight photography. In flashlight photography, we need a lot of light for a very short amount of time. Now, batteries usually cannot produce for us enough charges to flow through the light bulb to produce that much light. So what we do, we use a capacitor. We charge it up. That's when you turn on the camera, you charge up the capacitor, the flashlight capacitor. When it is ready, when you press the take picture button, then this is what's going to happen. See, so we had a lot of light for a short amount of time, and then there is no more light because the capacitor is totally discharged. Okay, now, of course, you see, instead of building and breaking the circuit like I did, we can do this in a continuous way. For example, let's do this way. Now we are going to charge the capacitor. Notice when it is fully charged, we don't have any more electrical flow. Here are charges, we don't see them flowing anymore. And actually, if I take an ammeter, I'm going to take a non-contact ammeter and put it over there, it reads 0 amps, no current. No current anymore, with our capacitor totally charged. Now we open the switch and no current again. So I'm going to close the switch to allow it to flow through the light bulb, and there you go. So the current was large, and it slowly diminishes. Okay, the value by which it's going to, the time it's going to take to come to 0 is going to depend both on your light bulb and on the capacitor. but we'll get into that later. Okay, that's the idea of a capacitor.